Hey everybody, Tom Cherryholmes here from the FujiNet project. Wishing you everybody a happy Thanksgiving. I'm slightly off frame here so we can see both the output from my Atari 8-bit and from my PC here just to take and demonstrate this next little bit for you. Now, what I actually have loaded up here is a copy of DOS 2.5. It has the latest version of the CIO handler for the end device actually loaded into place. It's a non-relocatable version of the driver for right now. I will handle relocation later because I'm still trying to put in all of the needed functionality that this thing actually needs in order to function. But with that, let's go ahead and do a little demonstration here just to show how, for example, a server, that is the Atari, accepting connections from the outside world and sending data to them and accepting input back from them would actually work inside BASIC. So we'll go ahead and start. We'll clear out what we have here. The driver's already loaded, and in fact, it's actually loaded off of the flash that's present on the FujiNet currently. I have a little 1050 here right next to my 1200 acting as kind of a temporary program storage area while I'm working on the next version of the next test harness, which will be a chat program called Tin Cans. But for now, I'm just going to manually demonstrate what the possibilities are. We'll start by essentially opening up a listening socket. Now, since this is CIO, it uses standard CIO idioms. The first aux bit, of course, specifies read and write, and with both of them together, that's 12, so read and write in both directions. But we actually use aux2 for various different things here for network control, and one of these things is bit number 8, or bit number 7 if you're counting from 0, which actually controls whether this is a listening socket or not. And if this is a listening socket, you need to specify, of course, the listening device port number, but you also need to specify what port you wish to listen on. Now what this actually did, if you heard that, you heard a little thoop, it actually took and wrote that command. CIO took and fashioned an SIO command to write that over the SIO bus to the FujiNet for a command called listen, or the L command. So now that this is there, and in fact, if we actually take a look, if we were to take a look at the debug output over here, which we're not, I don't have it up here, it would say it's now listening for a connection. So at this point, I can literally do a telnet over to my device here, open up a connection, and you really can't see it too much there, but it says trying, connected, and it's sitting there waiting. We haven't officially accepted the connection yet. So we have to use another command to actually accept the connection. Using the same parameters. Now the reason for this right now is currently because the driver is still in development and I'm not saving the aux1 and aux2 values from the open socket, which you're really actually supposed to do. If you look at the operating system source code, you'll see that they do this a lot, so you don't have to keep passing and remembering what values you set previously from one call to the next. Now what's actually happened here, you won't see too much of what's happening here, but we've actually accepted the socket connection here. And now we can actually read and write to this IOCB as if it were a disk file, as if we were talking to the printer. It really doesn't matter because of Atari's centralized operating system. Now I'm not doing any translation right now, so I'll go ahead and just simulate a carriage return in a line feed here, and we'll send it out the port. And if you actually see, we can see the testing right here. It shows up right here, bam, ready to go. Well, what about the other direction? Well, the other direction, let's go ahead and send something back. An interesting thing about Telnet's default behavior, if you know anything about how Telnet actually works, it sets up what's called a network virtual terminal, which specifies a whole bunch of properties that both hosts on both ends of the connection should share. And if you don't explicitly reset those properties through what's called an IAC sequence, it assumes that this is a line-by-line dumb teletype. So the telnet client will send its line one line at a time over to the host and vice versa. So hello from PC, we go ahead and hit enter. And if we go ahead and put a variable for this to go into and do a subsequent input, we'll see that it actually input this in. You'll notice that the screen color changed, and this is a debugging aid right here that I'm using to make sure that the buffer is actually being emptied properly. Now, because of the way that CAO get record works, it actually checks for an ATASCII end of line character, and it will stop reading after that point. So one of the things that the firmware actually does is it goes through and looks for character turns and line feeds currently and translates them to EOLs. This will be yet another one of these options that you can specify when you open up the socket. So with that, if we take a look at a string here, we can see the hello from PC. It's right there, ready to go. And if we add another line, we add another, and repeat the process. We can see that we get our lines one right after the other, and it works the same way with get and input here. So you can immediately start to see how you can take and do a simple protocol between two Atari machines to play a game or to communicate with an existing service. So if we go ahead and close the connection, it will cause a TCP disconnect right here, and you can see connection closed by foreign host, and there you go. So I just wanted to do this quick little demonstration so you guys could see where the CIO driver actually is at this point in time and give you an idea of a bit how you're going to be able to take and communicate back and forth. There's more functionality to actually be added, such as the ability to multiplex the same end device across multiple sockets to be able to handle multiple connections and not need 8 different end devices. That may be actually possible, so we can conserve the number of SIO devices that we actually need to do work, and to make it simpler to just open up a device and use XIO commands to take and say, okay, talk to this guy now, talk to that guy now, etc. So with that, I wish everybody a happy Thanksgiving. I hope everybody's having a good time, and I will be back sometime this next week with more videos. Till next time, guys. See ya.